If shoppers enter a store at an average rate of R shoppers per minute, and each stays in the store for an average time of T minutes, the average number of shoppers in store N at any one time is given by the formula N equals R times T. This relationship is known as Little's Law. The owner of the good deals store estimates that during business hours, an average of 3 shoppers per minute enter the store, and that each of them stays an average of 15 minutes. Therefore, the store owner uses Little's Law to estimate that there are 45 shoppers in the store at any time. And now for the question. The owner of the Good Deals store opens a new store across town. For the new store, the owner estimates that during business hours, an average of 90 shoppers per hour enter the store, and each of them stays an average of 12 minutes. The average number of shoppers in the new store at any time is what percent less than the average number of shoppers in the original store at any time? So here's the crux of the matter. The average number of shoppers in the new store at any time is what percent less than average of shoppers in the original store at any time. And then of course there's a little side note here saying that you should ignore the percent sign when you're entering this answer in the grid-in space. So this question is really centered on the number of shoppers at the store at any time, and we're given a formula that helps us calculate it. So we notice here that for the new store, we are given some data that there are 90 shoppers per hour, and that's a little bit of a problem because this formula works in minutes. We're told that T is in minutes, so that means those are two different units. So we have to first of all recalibrate this to make sure that we're working using minutes. So let's actually start there. All right, so we know that we have 90 shoppers per hour. We want to convert this to shoppers per minute. So we want to use this conversion. We know that 1 hour is 60 minutes. And thankfully, the hours cancel. That's the whole point. So we're left with shoppers per minute. Now let's actually simplify this. And when you do the math, this is of course a calculator section. So you end up having 1.5 shoppers per minute. Of course, it doesn't make sense, but we'll just keep working. You can't have a fraction of a human. But that's perfectly fine. We'll just keep working through it. Now, we know that we need to calculate how many shoppers are in the store at any given moment. And the formula was given as N equals R times T. So N equals R, we just found this out to be 1.5 times T. Now, how long were these shoppers staying? An average of 12 minutes, it said. In the new store, an average of 12 minutes. So 1.5 times 12. So we know at the new store, this is 18. That's to say that there's an average of 18 shoppers in the store at any given moment. So that's for the new store. Now looking back at the old store, we were told that there was an average of 45 shoppers in the store at any time.